Okay, we have a lot of information to cover, so let's get started. Welcome to our webinar of the expanding role of XML Gateways in SOA, mobile, and cloud. My name is Jamie Ryan. I'm the Partner Solutions Architect at Layer 7, and I've been working with XML Gateways for hands-on for about 7 years. I'd like to start off by mentioning that you can ask questions if you have a chance over in the chat window on the side of the WebEx interface, and we'll get to those at the end of the meeting. To start, I'd like to introduce our special guest from Forrester Research, Randy Hefner, and he'll be talking first. Thank you very much.
Yes, XML Gateways, they have been around about a decade. There was some time where they started with a number of smaller firms, and they're growing up and receiving a lot more utilization now. And initially, they had a fairly small and tightly defined sort of role, and now that role is starting to expand as the product space, as some of the ease of deployment, as a tight little drop-in solution, begins to be known and show its value across the market. So what I want to do is to position what that growth has been like, what some of the pressures have been, how the products have been expanding to meet some of the needs, and in large measure from customer pressures customers are seeing new ways that they can apply these, and it means in the end you should be thinking about the space in a little different way, well, and sometimes a lot of different way from where we initially were. So if you go back when, I said the space has been around for about a decade. It was first time in 2004 when Forrester had let the space develop enough that we did our first webinar on what's this space about, what are the products doing, and that we did our first initial product comparison in the space, and we're updating that product comparison now. We'll have more out later this year. But this is the overview slide that I used from that first webinar as to give an idea of the functionality, and it was basically 3 major groups of functionality and 1 very important side capability. There was first the attack protection, keep the bad guys out. There are ways to form XML messages that can cause XML parsers to spin out of control and the like. Trust enablement, let's let the good guys in. Let's make sure that we've got a dog at the door, being the gateway, who can make sure that anybody making a request is who or what they say they are, and that they are indeed authorized and entitled to get to the services that they're asking. Supporting those capabilities are acceleration capabilities that might be just pure XML processing capabilities, where we're offloading the heavy XML processing, but also cryptographic processing, whether that is SSL types of crypto, or whether it's crypto within the body of the message. So it's kind of the functionality, and it was very heavily centered on SOAP-based web services and XML processing, and there were a limited number of security models. It was based on two-way SSL, a little bit of PKI for encryption, and some PKI-based authentication tokens. SAML was just out. WS Security was making its introduction for SOAP-based web services, and that was largely the extent of it. So some of the scenarios, there were really 2 dominant scenarios that they were used for back in that time. The first was an external integration scenario, and so you might have any number of business partners, but typically a small number of business partners, and they would be doing SOAP-based integration into applications that were living and residing in your data center. So you'd put a gateway in the DMZ, and its core functionality was security. This both the attack protection side and the trust enablement side. As some of the products expanded to be able to help with certificate management among that community, so that when certs expired, you'd get notification and the like. And then it turns out that logging and tracing was very important functionality, because a business partner might be using one of your services and say, hey, your service is broken. Well, when you could look down into the detailed logs and tracing, then you could say, well, no, look at the message that you sent. It was a broken message. That's why it didn't work. And that was a very important sort of edge community, edge community management kind of function. But again, it was typically a small community, and this sort of community, by the way, was even though I was developing this early in the sort of SOA and web services lifecycle, even though a lot of folks said that people wouldn't do these sort of services externally. Well, an SOA Gateway at that time was very important, because it was just, as I said before, this drop-in solution, nice, tightly contained sort of security device. Internally, we also saw folks use the gateway typically in a security fashion, to maintain internal security and to be that one access point for services that might be hosted on a number of different platforms. Again, very heavily SOAP-centric, but the gateway might do a little bit of translation between protocols, a little protocol mediation to some message-oriented middleware, typically Java message service and maybe a couple others, but not much more. So that you had this one entry point into all your services and one place to implement an SOA security model for your internal services. So that was about the extent of it in 2004, and actually for a few years after that. But then we started to see some additional pressure, particularly in the last 3 years, maybe 4 years, to begin expanding the functionality and roles that these devices could play. The first was expanding messaging styles and content. So RESTful services started to make more headway in the market, and so we needed to handle a bit different messaging style. It wasn't all about HTTP posts for a SOAP message. We had to understand post, put, delete, and the full set of HTTP verbs, new content types, JSON, XHTML, and the payload of the messages. File transfer at the edge, where folks would see, well, we got this device there. Why can't we use it for some of the other connections that we have, externally? Internally, deeper requirements and deeper integration into mainframe and packaged apps began to drive more integration functionality into the devices. And so about this time as well, some people started viewing the SOA gateways as a substitute for an enterprise service bus product, and we'll come back to that question a little bit later. More interaction via email protocols, where you might have a service, potentially even a SOAP over SMTP kind of model. Typically more limited, that's less likely, but there's messaging that's going on via email protocols as well. Deployment options started to expand. Now, initially, you could get some of the products, not all of them, but you could get some of them in software form factors as well as the appliance form factor. But as we started to get more mature with service virtualization, then we started to see some form factors that would pre-package the appliance as a virtual machine image, and that model just extends up into cloud models, and in particular infrastructure as a service, and we'll talk more about each one of these types of requirements in some of the scenarios that we'll lay out ahead. And then finally, there is a rising realm of application contexts. So we'd be using them, the gateways, where the messaging body, the content of the message might be according to some industry standard B2B format. Any one of the many EDI formats or industry particular formats like Swift or Accord or others. You started to see, a desire to put some control and access and security around connections between rich internet applications or AJAX architectures, running out in a browser, and the back-end piece of that architecture, because in those, typically in a rich internet and especially in an AJAX architecture, the UI layer is really split between the browser and the back-end server that's doing some UI servicing as well as doing business logic and the rest. So have some messaging there that we'd want to lock down a bit more. Then we can look more particularly at cloud resident solutions and the different types of cloud, and the three major ones being software as a service, platform, and infrastructure as a service. And each one of these now, as you're connecting to solutions that are running in these environments, is an opportunity to pre-populate the device with some capabilities for understanding these environments and making it easier to connect to, manage, secure the environments. Mobile apps set up new kinds of messaging patterns and proxy requirements. And then we start to see the rise beyond just the Amazons of the world and the like, of having these broad-based open APIs, very often RESTful APIs, that we're intended to open our business to the whole of anyone out there on the internet who wants to, quote, be our business partner and interact with us in a service-based kind of way. And those bring up some new requirements as well. So let's look at some of the scenarios that drive this, and we'll start with an internal scenario, going back to the situation of a scenario that's internal. And my environment, my WebEx browser just stopped responding. So let's see if it comes back. But Jamie, can you make sure that I'm on, or Sarah, can you make sure that I'm on slide 7? And with internal service control, the first sort of environment that we see folks using is a scenario without an enterprise service bus. So using the SOA gateway in a way that it is acting as a service bus in some sense, and in this environment, now this is the situation, whereas it used to be very SOAP-centric, now the situation is such that we have multiple formats that a service-consuming application might be calling via. Maybe the service application is in the I'm just seeing a note on the chat that we haven't been able to move to slide 7. Let me see if my environment started responding again. There we go. Yeah, I don't know what happened to my computer for a moment there. So we have multiple protocols coming in on the front end, and multiple different formats. And my apologies again for the slowness of the environment. Every time I click on the WebEx control center, it takes it a long time to respond here. Sorry for the technical difficulties. So very good. Oh, there we go. Now we've got the slide built out there. You should be seeing some blue text on it now if we're back in sync. So multiple formats coming from a service-consuming application. Maybe the client application is doing SOA with JMS. And for example, some recent Forrester data shows that although REST is on the rise and many people are interested in REST and examining it for future usage, it actually turns out that second, SOAP is still the dominant protocol used for SOA, but second to that is XML over Java message service. So a service-consuming application might be using a JMS messaging that's being brokered by way of content, by way of protocol, to between any number of things. So we have much broader requirements now for brokering between many different kinds of content, the XML, JSON, COBOL copybooks, EDI formats, and many different messaging styles, whether it's SOAP, REST, MOM, email, FTP. Receive a file, send it out as a series of individual messages. These kinds of things. But it's still that same diverse application platform on the back end. But we're also seeing folks now finding that it's very useful to put an XML gateway, an SOA gateway, in combination with an enterprise service bus. And in this type of scenario, what we often see is that the enterprise service bus is called on for the big heavy lifting of integration and deeper service construction requirements, and the enterprise service bus might have a library of adapters that it includes and various other kind of deeper integration and more development kinds of models, versus the SOA gateway having a more configuration or a policy-based model. And the SOA gateway might then be doing security and some high-level control via policies for filtering services, creating a virtualized service out of a number of, where one service underneath looks like 2 or 3 different services externally, because it wants to be filtered for different audiences. So again, all inside the enterprise, we see an SOA gateway being used both with an enterprise service bus and separately, independently of an enterprise service bus. Then, if we begin to look outside at some cloud integration scenarios, well, first we'll look at platform and infrastructure as a service, and now we have the issue that want to maintain very good control and access either way, either a service consuming application on-premise accessing a cloud-based app, and here we're going to talk about a custom app because we'll talk about SaaS on the next slide, or potentially an app in the cloud calling back to some service that's residing on-premise. The other type of thing that goes on here, though, is that the IaaS and PaaS environments provide management APIs to control when you scale up and scale back instances, and gathering data about performance and capacity, and adding storage, removing storage, doing backups, any number of things where you might want to control the IaaS or PaaS environment, and often those are exposed via APIs that may be SOAP, they may be REST, but in Amazon EC2's case, it's SOAP, or it's an HTTP query parameter API, so not even REST. It's you even push one level back from REST, if I can put it that way. And so we have both of these sorts of requirements, managing the platform and doing the work of the application. And in this case, the gateway might be residing on-premise or in the cloud, either one. So I put it on the line here, or both for that matter. And often what we see now is the products being pre-configured in some way for understanding and knowing the environment. Or what might be happening is that additional protocols and additional patterns are being built into the gateway that may be useful they're being put there because they're needed for a cloud environment, even though they may be just as useful even if your application is only on-premise. So we're seeing new security things, particularly in relation to SaaS. And the SaaS scenario, I think, is very interesting because all these other scenarios we've been talking about were still pretty much the way the broad model that you've understood of there's some messaging between applications, but a different kind of thing comes up with SaaS. And what we see is that what we want is to achieve some level of single sign-on, but our existing single sign-on system may not understand the SaaS application and its tokens and the like. Well, the SOA gateway now can intercept that HTML, HTTP message, perform some single sign-on against an ID management system, format tokens that are needed for a SaaS application, potentially supporting newer protocols like OAuth and the like. So Here the message, so to speak, is really a UI level message, pure and simple, but the gateway is again able to extend its role into that. The last scenario that I want to highlight comes back to this broad-based B2B environment and capability, and you know, that I mentioned, where initially the applications in the scenario were about smaller communities for B2B kind of integration, and now with these APIs, Amazon has been there for a long time, you know, so that you can sell books from and whatever else from Amazon on your own little mom and pop website or a big company website. Now there's APIs into Facebook and a number of others. Well, Sears and other you know, more traditional companies are also now getting APIs into their environments, and so. Oh, wait a minute, I skipped ahead of myself. I've actually got one more scenario before I get to my last one. My apologies. I'll come back to the broad-based open APIs, but the other thing, building on this user experience kind of level of integration from the SaaS scenario, we see a couple of different user experience kinds of things where the SOA Gateway is playing a role now. The Ajax type of scenario where the message going between the browser and the back-end environment is sort of inside the UI layer of the architecture, and we want to, you know, control and authorize those. But then also mobile apps, which create, you know, new kinds of interactions between mobile apps and mobile platforms that might bring in some proxy requirements and other things that an SOA gateway can meet, as well as just generally bringing back into play the attack protection side of the platforms. So then, now that last scenario. So you get these broad-based open APIs where you know, maybe, you know, it's not just major business partners, but mom and pop shops, maybe hooking into Facebook apps, and you got any number of boutique web developers doing their thing, potentially even individuals, you know, doing their own custom integration with your site, depending upon what capabilities you provide. So here a couple of things come on. Number one is a much higher volume of user accounts. So whereas in the older B2B scenarios, it was very practical, or at least doable, to do a two-way SSL connection to secure a small partner connection, that's no longer acceptable with the very broad community. There's just too much cost to managing certificates on the client side for all these. There's also so you have to have a one-way SSL connection, which brings a higher risk of attack protection and brings additional kinds of requirements and scenarios. But also with the broader community now, then there's greater need for public documentation and forums and other surrounding requirements that aren't really about using and protecting the APIs, you know, in a technical runtime sense, but they're about the community and managing around that. So that provides some other opportunities to think about the whole space of API management versus just making sure that you're securing the gateway environment. So what do you do with all this? Well, the first thing that I want to say is expand your thinking about SOA gateway usage scenarios. And the best way that I can say it, and maybe this is at the risk of going too broad, but really it's sort of what's driven the expansion in scenarios of these devices, is where there's a message-based interaction, a gateway might help, of whatever kind the message-based interaction is. A gateway might be able to add some value to the scenario, and there are clearly very many message-based scenarios that a gateway can play straight into. And again, one of the big reasons people choose the gateways is, you know, the other products that, you know, in different categories that might, you know, meet some of the requirements, but often it's because it's an easy drop-in solution at the edge. So when you evaluate these products, considering how this space has grown, usage scenarios change, and the like, that it makes some broader requirements, aside from just the core requirements of the product, it makes some broader requirements more important. So clearly you still want, the security protocols that you need, and if you're doing SOAP and WS security, you got to get support for that, and you got to get support for any low-level technical requirements that you need. But you also want to consider extensibility. How can you extend what this device can do, and what options are provided for you? Because as you see new scenarios, it may require, if you're running ahead of the pack, it may require, a little bit of custom work. And how can you add that in and extend the capabilities of the device? Upgradability. Some of the products in the market have more than one version, more than one edition, if you will, with ranges of functionality. Can you go between them easily? Can you deploy the same functionality in multiple different scenarios? And then how well does the product integrate with your existing security infrastructure, whether it's identity management infrastructure, auditing and compliance infrastructure, or whatever it might be? Those requirements are expanding. Those have been, obviously, that was one of the core requirements on my very first slide, and that I did from 2004. But those continue to be very important requirements. So then you can begin to think about these different ways of integrating your gateways into your overall platform, not just for SOA, but beyond SOA. So maybe in these different connections and scenarios, but in the UI layer, in the services layer, maybe even in the data layer, particularly with data services being a very important growing use of SOA and messaging in the market. Internal versus external scenarios, large and small communities, and on-premise versus cloud. These all become new ways and dimensions to think about how you might use these products and how they might be applied in your scenario. Jamie, back over to you.
Thank you very much, Randy. That was a great introduction to kind of the space and what you see in your customers. I'd like to talk about similar topics. But I'm going to take a bit of a different approach. So, just a second. Here we go. So I'm going to talk about gateways in general as we see them out in the marketplace and with our customers. I'm going to talk about some of the same kind of groupings of use cases that Randy discussed. I'm going to talk about the challenges in each use case that we see, kind of real-world scenarios where you've got new regulations or new standards that you need to support, and the SOA gateway needs to support that as well. And then I'm going to talk about the Layer 7 approach to a solution for each of these challenges. So, as Randy mentioned, XML gateways are kind of the intermediaries between service providers and service consumers, and that goes all the way back to that first slide, the 2004 slide. But really, this scenario replays itself over and over again. It's kind of the same architecture no matter what deployment model you're talking about. So the consumer could be a partner corporation, it could be a different division within the same company, it could be a mobile phone user, it could be a SaaS subscriber, and then the provider could be a health insurance company, a bank, a retail giant, a cloud provider. Doesn't really matter what's on either end. The gateway sits in the middle and is an intermediary for policy enforcement and governance. Traditionally, Randy mentioned that they sat in the DMZ and served as kind of a content-aware application-level firewall. The defining characteristics were configuration rather than coding. It was a drop-in piece of architecture, so generally hardware, though we'll see how that expands. Security was a first-class citizen, so security is important, performance is important, and support for multiple message formats and protocols, and we'll see how that expands along the way. But in general, XML gateways can be the common denominator across a wide number of deployment models as they introduce new features, new form factors, and new use cases, support for new use cases and standards. So because they have the same basic architecture, if you can implement this appropriately, you can really kill a lot of birds with one stone. So I'm going to start on the SOA security. This is basically any time that your application traffic or data is crossing network boundaries. So initially it was SOAP over HTTPS, but it could be B2B commerce standards like EDI over AS2, could be FTP deliveries of raw data, so any of those kind of edge scenarios. Then we move to internal mediation and the ESB use cases that Randy mentioned. So you moved inside the firewall, and it starts to overlap with some of the traditional ESB use cases that are connecting applications or departments within a company. And we'll talk about various permutations of that. So when it can exist on its own and when it needs some support from other pieces of the architecture. So then you take your applications that are being provided to partners and or provided internally, and you want to push those to the cloud, whether it's a public cloud or a private cloud. That introduces a whole new category, and there are some unique challenges based on the style of cloud deployment that you choose and your perspective. So if you're a cloud provider, that's going to be a lot different than if you're just deploying apps to the cloud or just connecting as a consumer to software as a service. And then you want to expose new interfaces to the public. So you want to get broader adoption of your services or technologies on a greater number of platforms, and particularly mobile, because that's the hot space right now. But we'll talk about why it's more than just mobile and becomes kind of an API management problem rather than just a mobile problem. So first, SOA security. And the reason we're talking about this first is because security still matters. So this harkens back to Randy's initial slide from 2004, but the deployment pattern is just as relevant today. So there's actually a growing demand for this traditional security gateway use case, and there's two main reasons for that. The first is an expansion of existing SOA deployments. So these are early adopters that now have a large ecosystem of services that are exposed to a larger number of consumers, and for the most part, they're worried about access control. So they've got core financial data or customer data that's being delivered over the internet, and they want to make sure, based on your credentials, that you have access to the appropriate data and no more. So they need to worry about things like two-factor authentication, OAuth, and other new access control standards. They have to worry about compliance audits to make sure that they're handling your data privately, et cetera. The other reason this demand is growing is because of recent adopters. So often these are large conservative organizations driven to SOA, and they're driven to SOA by new use cases. Those new use cases come with new regulations, and those new regulations come with new security standards that have to be supported along the way. So I wanted to talk about a few specific examples. In the energy and utilities industry, smart grid applications are really all the rage right now. There's a lot of federal money in it, so power companies around the country are deploying these smart grids. But you want to be cautious about that, so there are regulations called NERC-CIP, which are there to protect critical infrastructure so that you don't have access to too large a portion of the power grid. So XML threats or any threats can't shut down large portions of the infrastructure or power grid with a single attack. Similarly, there are new standards that people want to support. So one of the biggest is elliptic curve cryptography. So this allows the smart meter outside your house to talk to the power company's IT infrastructure. It's just a new algorithm for doing security in those kind of embedded devices. In the military and intelligence communities, there are new requirements around information sharing. So across UN and NATO member countries, in battlefield deployments, they all have to share their data so they know, so there's no friendly fire incidents, those types of things. But they need to be cautious. Obviously, the government, anytime they expose this type of data, they're going to be cautious about it. So they've They're worried about cyber attacks, data proliferation problems, like with the WikiLeaks scenario a couple months ago. And so the DoD has implemented security implementation guides. So these specify that anytime you have external communication with web services from an internal network, you have to have an XML firewall in place. So new use cases, new standards. In the retail industry, people are coming up with new virtual marketplaces every day, so different ways to sell their goods. And the common need is for payment processing. So you have to be able to process a credit card to get your money. The payment card industry has responded by coming up with this PCI DSS standard, so data security standard, for how you handle credit card information and other personally identifiable information in these types of payment processing scenarios. So it tells you how you have to handle it, how it has to be encrypted anytime it's at rest, and then they impose fines if those requirements are met. So all those are real challenges for the traditional security model, and these are the types of cutting-edge security requirements that Layer 7 is solving every day. So our Layer 7 SOA gateway appliances are, as Randy described, the kind of early use case, hardware appliances that are deployed in the DMZ and protect and secure your data and application traffic. We'll see how that expands in a minute, but there's a broad list of security certifications and standards that we support. I won't go through the whole list. You can look at our website if you want that. But the two biggies are FIPS and common criteria. So we're 140-2 cryptographic certification in both hardware and software. We're EAL4 certification for common criteria. And then we support a lot of the use cases and regulations that we just talked about. So NERC CIP, kind of firewalling that data. We are compliant with PCI DSS, as well as certified for the Department of Defense implementation guides. We provide a wide variety of access control, starting with different token types. So support for lots of different token types. We take those tokens, those credentials, whether they're username and password, in a message, in a basic auth header, in a WS Security username token, or non-username and password certificates, Kerberos, SAML. We can have a wide variety of authentication mechanisms that we can integrate with to validate the user. And then we can authorize those users using a number of standards as well, and with flexible granularity. So you can authorize those users based on the service they're calling, or the operation they're calling, or even content within the message. So you have access to the entire payload and transaction context. Layer 7 also provides a full onboard security token service for true identity federation between domains. So you can take a username and password, get some information out of an identity repository, and provide a SAML assertion to a back-end resource. In terms of data security, so I've sandwiched about 2 full presentations worth of support into 2 lines, but suffice it to say we have a wide variety of data security and threat protection mechanisms, including support for some of those cutting-edge standards like elliptic curve cryptography, which very few vendors are actually supporting at this point. So then you take that security out in the XML gateway, and you move it internal. So even back in 2004, that internal service control was just as important as edge security, and so those XML gateways were brought into the enterprise to do security, and as customers were implementing them, they found that there was an overlap with traditional ESB deployments. So as a level set, Randy already talked about ESBs, but I just want to say ESB is a pattern for application integration, not necessarily a product, and it involves exposing some technology platform that implements certain requirements. So those requirements include message format transformation, protocol mediation, content and context-based routing, but there's more to it than just those basic requirements. There's some non-functional requirements that are just as important, and this is where XML gateways begin to be attractive. So those non-functional requirements include security, ease of use, time to market, and total cost of ownership. So traditionally, ESBs have been kind of code-heavy, long deployments, not very agile, and they've been kind of put out there as products or platforms by ESB vendors that don't really care about the particular needs or requirements of a specific customer. So as those requirements have expanded, there's also been economic challenges that have needed to expand those requirements as well. So you need to do more with less. We've seen it time and time again in big businesses right now with the economic challenges. You need to meet changing customer needs, implement new features, and expose new data, but you need to do it quickly and more agilely. So the configuration, not code approach of XML gateways has really provided a benefit for people in these use cases. And as Randy mentioned, there are new use cases, new protocols, new message formats around REST and JSON and legacy integration to mainframes that all provide reasons to go with an XML gateway type of deployment. And generally, when we see these deployments, we see them in three different ways. So every vendor in the space will give you a laundry list of all the specifications that they support, all the message formats, all the protocols, all the different things you can do. And if you can look over that laundry list and see that that meets all of your needs, then the gateway really can be a standalone ESB. So it doesn't need any other ESB deployment. It can do all of that transformation and routing capabilities for you. If you already have an ESB and you're happy with it, but you might need some of those non-functional requirements like security, or you want to offload some of the heavy lifting, then we see kind of an ESB gateway use case where you have your traditional ESB and the SOA gateway provides an on and off ramp to that ESB deployment. So it does the heavy lifting around transformations, around security, and just provides that data to the ESB for more of the back-end logic. And then a federated ESB. So this is generally in large corporations that have grown through mergers and acquisitions, and they have a heterogeneous IT infrastructure. So one division has .NET, one division has Java, one division has an ESB, one division doesn't, and the SOA gateway can kind of provide a bridge between those different departments, and it can provide a full ESB, kind of a standalone model for the departments that don't have anything and need something. So there's several different ways that this ESB pattern can be solved by SOA gateways. So as it probably was apparent, that ESB pattern is all about connectivity and integration. So Layer 7 takes this very seriously, and we provide kind of a self-sufficient governance platform with broad standards-based integration for connectivity to external systems and other internal systems. So these include registries and repositories. We can connect to external monitoring systems, or you can use our monitoring system, so you can monitor traffic without the need of an external product. We can do auditing and logging either on the box or by pushing it out off the box. We can do SLA enforcement. We can do routing, but also much more based on content and context. So you can really do just about anything, any level of orchestration based on information within messages that you're seeing flowing over the wire. And then for maximum flexibility, we have things like workflow constructs and direct database access and a configurable caching mechanism that you can decide when to employ. Lots of other fun features like that that really provide agility and flexibility. So again, I won't go through the full laundry list, but there's a wide range of supported transports. We also provide a transport API for defining new transport layer protocols. So if you have a custom socket protocol that you need to support, we have an API, you can write your own integration, and that becomes part of the product. We also support lots of built-in message formats, both for validation and for conversion. And then we can really do any-to-any transformations for custom formats. Okay, so let's move on. So you've got your applications deployed in your data center. They're protected and governed by your XML gateway, and you're starting to think about the cloud. So cloud is just another place to deploy your apps, right? Not quite that simple. So the main reason it's not that simple is you start to lose control as soon as you move to the cloud. Depending on the type of cloud deployment, you give up a different level of control. So infrastructure as a service, you're giving up the hardware, networking, and storage control. If you're doing platform as a service, then you give up some of the middleware choices and some runtime functionality. And if you're doing software as a service, then you're basically handing over full control to Salesforce.com or Google Apps or whoever your SaaS provider happens to be. So there are a few requirements that come out of this. If you're just trying to deploy your apps to the cloud, then you need a secure perimeter for those applications. So it needs to be around your apps just as the kind of XML gateway or SOA gateway was around your applications in your DMZ. If you're a cloud provider, then you also need to manage your APIs and orchestrate things like instantiation of environments and governance of your infrastructure itself. So that's kind of the service provider model. If you're a consumer, then you have new challenges. So governance of your cloud usage. As Randy mentioned, you need some sort of single sign-on to your cloud applications, so you need to support some new technologies. And you want secure integration between your on-premise applications and those applications that you choose to live in the cloud, whether they're your apps or not, and whether they're a public cloud or a private cloud. So the way Layer 7 addresses this, how do we provide the same level of security, governance, and operational management in the cloud as we do for you in your own data centers? So the first thing is, if you want to deploy your apps to the cloud, you want to enforce the perimeter. So the same functionality that's available in a hardware form factor for those edge security use cases is also available as a VMware image. It's also available as Xen-based VMs, as an Amazon AMI instance, or as a software installation. So really it provides identical functionality that you get in your data center and in your ESB deployments, but now you're in the cloud. Layer 7 also offers a freedom license for maximum flexibility. So it's easy to switch between these form factors. It's easy to upgrade your hardware, upgrade your functionality in software or in these image-based deployments. And then the gateways are also available as a subscription model. So you can do security as a service just like you're doing software as a service. Next, if you're a cloud provider, you really want to secure your platform. So our Cloud Control product provides API management to manage access to APIs and orchestrate data center activities such as environment instantiation. So you can do things like send out an SSH command to spin up a database, a new database instance. So you can actually orchestrate back-end technologies based on the APIs that you're providing to your cloud customers. If you're a consumer, then you'll start to worry about secure communication to the cloud. So our Cloud Connect product helps with that single sign-on and data security between your on-premise applications and your cloud applications. If you know that there's a Layer 7 gateway on the other side, then you can use an XML VPN client to automatically discover and configure kind of the end-to-end security settings between the data center and the cloud. So as settings and requirements for security on the cloud deployed app change, your kind of first-line gateway inside the enterprise also changes and updates itself to match those security settings. And then you want to streamline your software as a service connectivity. So Layer 7 provides templates for connecting to common SaaS providers like Salesforce and Google Apps, and those are growing. The number of those are growing every day. So now you've got your applications and services deployed internally, deployed externally, deployed to the cloud. Now you want to open them to a broader market. So you want to extend your reach by providing data and technology to mobile customers. So how you address security and governance in that space? Well, the challenge is you need to cater to the needs of multiple audiences. So your enterprise architects want to retain control over the execution of those services and the security around your data. You might have a community of developers that want to provide value-added interfaces to your data, and those can be internal developers or external developers. It doesn't really matter. Certainly it matters the way you enforce your policies, but the concept is the same whether they're internal or external. And then you've got a group of end users. So all they really care about is easy, reliable access to cool technology on multiple platforms. And that multiple platforms is where we get into kind of the distinction between mobile and API management. Because certainly right now, the most common use case is I want it on my smartphone or I want it on my iPad. But really, people want access to these apps just about anywhere. So that includes gaming systems like Xbox and Wii. That includes printers now that have little apps built into them. That includes refrigerators that will order more groceries for you or put together a shopping list for you. So all of these things, basically anything that can connect to the internet and run an app or write to an API can be deployed out there. So you need to worry about API management in general rather than just mobile. So to support this new paradigm, you need a few different things. One, you need developer enablement. So from the enterprise perspective, you want to enable your developers to write these kind of value-added applications. You need runtime control, and you need analysis of usage and service lifecycle management after the fact. So Layer 7 addresses these challenges with a three-pronged approach. First, we have a feature-rich white label API portal for developers. So this is a fully customizable turnkey portal for managing access to your developers and to your API administrators. For developers, you want to be able to self-register, sign up for API keys, check on end-user usage. For API administrators, you want to manage rate plans, provide support, view kind of holistic usage across developers and across end users, and cater to those system integrators and developers that really provide the most revenue to you. So we've got a full CMS for downloading documentation, getting support, interacting with other developers. And if you have an existing portal, you can actually integrate that existing portal and feed policies to our runtime API proxy. So at runtime, we rely on that same enterprise-grade security and mediation capabilities that we have for all these other use cases. We have multiple deployment options, on-premise, off-premise, cloud, but you're able to keep all of your data internal so that you don't have to expose it to a third party just to manage your API usage. And then we've got a library of kind of mix and match security operations that you can use for defining custom API security, including various flavors of OAuth. And then because we have a robust, scalable platform that's designed for the enterprise, even a single API proxy can handle up to 25 billion transactions per month. So last but not least, the API lifecycle. So you want to be able to author policy, you want to migrate between environments, and monitor real-time and historical data over a number of different criteria, end users, developers, APIs, and use this information to make business decisions. So I know we're running short on time. I know we've covered a lot of content in a pretty diverse group of use cases, but hopefully this gives you an idea of the power of XML gateways in general and how Layer 7 addresses these modern IT challenges. And now we can move on to some questions. So when clients need to access 2 or more web services and authenticate only once, can that be possible through the SOA gateways by generating a SAML token on the first authentication instance and propagate SAML, do a kind of federated SSO, and give access to end chain of web services? So absolutely. So we've got both the orchestration capabilities that allow that and the security token service that allows for that kind of trading of credential information. So you can look up information in a repository, validate your user, and then provide a SAML assertion with sender vouchers that goes on to the next web service and does the next step in the chain. So we can provide the first line of security as well as that last mile security with various different protocols.
Jamie, I'll jump in with a couple of questions. There's one, can you use the cloud as an overflow option if IaaS is saturated in the enterprise's local infrastructure? The easy answer to that question, or the short answer, is yes, but yeah, there's a lot of architecture and planning that you have to do to that. Some of the cloud, the tools around cloud, I mean, this goes far beyond gateway kind of questions, but some of the tools around cloud are hoping to make that kind of thing easier in the future. But wait and see. But yeah, you could do it now, but there's a lot of hand wiring. How can you assure that in a B2B scenario, both partners don't reside in the same cloud and increase risk of QoS and failures? So one thing about the cloud is you don't know where anybody is. And you don't even necessarily, I mean, you have some control over where you are, but you don't know what machines you're on. But bottom line is it's intended to make it transparent, and so that really is beyond the realm of what you can consider. If there are some particular business requirements in a B2B scenario that need to manage that, that would have to be managed at an organizational level, where you would have to, each partner in the B2B network would have to share where they were running, and you'd have to mediate yourself that, some way amongst yourselves.
Yeah, let me pitch in on both of those too. So the cloud is an overflow option. The simplest use case is you already have that cloud deployment set up, and you just need to kind of move from on-premise to off-premise based on quality of service. So our orchestration capabilities, you can make decisions both on content, but also on traffic conditions. So if the on-prem isn't behaving or is getting saturated, you can move to the cloud. Obviously, it gets more complex when you're talking about instantiating new cloud environments, and that's a bit dependent on the APIs that the cloud providers expose themselves and how much control you have over those.
Oh yeah, important. Yeah, you pick up on the simpler case, which is important. I left out. I was doing the more difficult case where the application has to kind of know between and their state between the thing. But yeah, if you just got the simple same service running in both, then yeah, a gateway can do that really well.
Yeah. Are there any more questions on there? Is this on the boundary of the network or domain? We're talking about an ESP like data power typical. So we've talked about multiple deployments. It can be on the boundary of a network or domain. It can be internal. It can be in the cloud. It's similar to a data power appliance model, ESB, but with a little more flexibility in terms of the form factors that are available. So you can actually put this in the cloud because it's even a public cloud, because it's available as a virtual image. It's available as software. It's restricted to that kind of hardware deployment model.
Yeah.
Why XML? Sorry, XML VPN client. So the naming of this XML VPN client kind of throws people off. Certainly, you can have a standard VPN for connecting to a cloud, SSH tunnels, that type of thing. The XML VPN client is a specific optional Layer 7 product that kind of is aware of Layer 7 gateways and their configuration. So if you're enforcing data encryption and digital signatures and SSL and a particular username token type in your cloud deployment or in your external deployment, and you have a local installation of the XML VPN client, you can actually connect through that local gateway, and it will handle the design time communication to understand what security requirements are there and to update the channel appropriately. Any other questions in here? How do you handle massive XML data volumes, transformation between one format to another in a SOA gateway? So like 2 gigs of a single XML file. Obviously, as soon as you get into large files, it's going to be a challenge for anything, but we really do have the performance capability and the horsepower to process these types of large messages in a fast and efficient manner.
You know, there's one, can Gateway be used to intercept and audit secure data crossing the enterprise boundaries? Most definitely, but you got to make sure that the data is recognizable in some way. So, a social security number, a credit card number, if it's in an XML stream and the XML tags that are identifying it are known, then it can match that. Potentially could match a social security number or some other identifying number by pattern. 3 numbers dash, 2 numbers dash, 4 numbers. Okay, yeah, you could recognize a pattern in the data like that. But you've got to make sure you have something like that the gateway can look for. Because if you don't, then data can get through. So there's more governance that's required, but the gateway can play a big role in it.
Yeah, threat protection is definitely important, and you want to do things like SQL injection filtering and cross-site scripting filtering, but you also want to, whenever possible, employ a more positive security model. So you want to know exactly what type of traffic is going to be provided. You want to know the schema that is the format that it's going to be in via schema, JSON schema, an XML schema, whatever it may be. And you want to validate that data that you're expecting and really filter out anything else. So for a particular operation, you know that the message is going to arrive according to a schema. You can schema validate that. You can look for specifics like Randy mentioned, like social security number, and make sure those are in the appropriate format. You can filter out particular dirty words or particular elements. So there's lots of functionality when you know exactly what the traffic is going to look like. So that application awareness is part of the strength of this type of gateway. Could you show us a demo of the Layer 7 SOA gateway? Certainly, there are tutorials and videos of recordings of demos on our website. I don't think it's quite appropriate for this webinar, but if you follow up with us either at info@layer7tech.com or directly to me, jryan@layer7tech.com, we'd be happy to get you set up. Thank you, everybody, for attending. And if you have any questions for me, you can follow up with my email address or go to the Layer 7 website. And thank you so much, Randy, for being our special guest and giving us your insight.
Thanks for having me along, Jamie. Always appreciate it.
Yeah.
Always fun. See you guys.